I want to say it's Kaylee. Okay. For some real numbers, M and N. So numbers mean they could be decimals, right? They don't have to be integers or anything, yeah. So let me get this fixed. There we go. Okay. The list 3n squared, m squared, and 2n plus 1 squared. For the questions, can I ask you to explain like a concept or not? If it's related to a question, yeah. Some students say like, hey, can you just explain the quadratic formula? I'm like, no. Give me a problem involving the quadratic formula, and I'll explain like why it works. Jeff says, you know, 2n squared, 2n plus 1 squared minus 3n squared equals 2, which makes it easy. Oh, wow. I didn't know that. Consists of 3 consecutive integers written in increasing order. Determine all the possible values of n. Oh, very good. Okay, yeah, so if they are in consecutive order, that's actually really cool. So consecutive, oh, and they are integers. Well, 3n squared is an integer. Which I get, does that imply n would have to be an integer? You can't have n be a fraction and somehow square it. Or I guess maybe you could, right? Couldn't n be equal to like 1 over the square root of 3? And then 3n squared would be equal to 1? Oh, I guess it could work like that. You know m and n are real numbers, yeah? Beat that. Sometimes do you wish Epstein kidnapped you when you were 7? Y'all gotta chill, dude. What? Okay. Consecutive integers means that they go up in order, right? So for instance, like 2, 3, 4. These are consecutive integers. And what we know is that, yes, the difference between the last and the first consecutive integer should be 2. TikTok always wilding. So, that means this one's the last one. This one's the first one. So yes, by Jeff's assertion, 2n plus 1 squared minus 3n squared must be equal to 2. This is like very easy. Julian, dude, I wish Epstein didn't fumble the bag, dude, because like Gilan was hot, dude. What the fuck is he doing with children? That's the biggest crime, dude. He fumbled the bag. Okay. There we go. Yes. So m. Well, wait. Well, let's get n first. You think n equals 0 or 4? Let me do this out. So 2n squared plus 4n plus 2 minus 3n squared is equal to 2. So negative n squared plus 4n is equal to 0, right? Because then these cancel. Yep. Oh, this is nice. Okay, so then you pull out n, and that's 4 minus n is equal to 0. Good, so n equals 0 or n equals 4. I agree. Do they say they have to be positive? No. Okay. Great, okay. And then if m is in between these two, right? That means this minus this. So the last term minus the second term has to be equal to 1, right? And then also the second term minus the first term is equal to 1, right? So these are some other conditions. M squared minus 3n squared has to be equal to 1. And then also this mess, 2m plus 1 squared minus m squared has to be equal to 1, right? So then let's just choose some values, right? You're feeling so it feels like 1? Yeah, exactly. Okay, so let's just compute it, right? So let's do like case 1, which is that n is equal to 0. In that case, you get m squared is equal to 1. So what, m equals plus or minus 1? I sound much better on TikTok than I do on Discord. Interesting. What about Twitch? How do I sound on Twitch, Fanatic? I'm curious. M equals 1 only. Because 0, -1, 2 doesn't work. Oh, I guess so, right? Yeah. 0, right. Well, wait a minute. No. M could be -1. Because -1 squared is still just 1. Discord audio is ass. Oh. Teach me. Wait, what? That's fascinating. I didn't know that. Ass in what way, Star Prod? Is it distorted? Is it clipping? You broke math, dude. Okay, that was your one mistake for 2026. You get one. Yeah, so I think M can be plus or minus 1. Oh, it's bitrate? Oh, interesting. Let me fix that then. Sorry. Let me fix it. Maybe the quality just needs to go up. There you go. Oh, it sounds... Okay, good. Thank you. Just checking. And I guess... Does that solve this as well? Right? Right, yeah, okay. Well, okay, but wait, Jeff, right? If n equals 0... Doesn't this give me that m squared, negative m squared must equal 1? Oh, okay, and that does work. Okay, fine. So we're good. Wait, no, we're not good. Wait. Why does this actually not work? Wait, what? What the hell? No, it does. Wait. Yes, sorry, because this is 2. 2 minus m squared is equal to 1. Okay, I accidentally got rid of this. Okay. Thank you. Yeah. See if it's improving on Discord. I don't know. All right, let's try case 2. Good. All right, yeah. All right, case 2 is n is equal to 4. So, okay. Sure. M squared minus 48 is equal to 1. M squared is equal to 49. Yeah, it's because, yeah. There's always going to be 2 values for this, right? Because it's m squared. You get a plus and a minus. Yeah. Okay, cool. So the values for m are plus or minus 1 and plus or minus 7, I believe. We agree with that? So 4 different values, I think. Applaud? Okay, cool. We'll give it to us. What's up, Sears Tower? I'm glad you know how to solve it. All right, that one was Shank Tricks. Clap, 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 clap. All right. Marking is done. Good question. That one wasn't too bad. Hey, it looks fun. I'm glad. Join in on the fun. We just solved it. Our answers were m was plus or minus 1, or m was plus or minus 7 is what we got for this one. But let's go to the queue, see what else is on there. Again, if you're watching us from any of the other platforms, the website actualofficehours.com is the best place for you to submit a screenshot, and we'll go over it live here on the stream. So go to the website, check it out. We're going to click here on the live queue and see what we got. So next question is from StarProd. Oh dear. StarProd. All right, I'll do one of yours. Then I'll do the other one later. What's up, Amir? We're back. Oh man. I think I just want to do. Wait. What the hell? I don't know why I logged out automatically. All right, let's do this one. I'm gonna do the second one. I'm gonna do the last one. Yeah, I really don't want to do the first one. This has like too many words on it.
No.
Yeah, and all these things about like retinas and corrective. Dude, I hate these questions. I'm like, just, I don't know, just wear some glasses. Oh, the third one. Oh, you submitted 3. Oh, okay. Oh, dear. Okay. I am going to post on TikTok, Amir, next week. I have a short I've been working on. We do a lot of lives on TikTok, but yeah, you're right. My last helpful content post I've made was probably a year ago. You just want to know the light rays and stuff? Sure. Okay. Okay. Where to put the eye? Oh, all the light rays are parallel? Sure. Okay. I agree. Can we just come up with like one object, I guess, right? Psycho says refracting telescope has a focal point between the lens and the rays are parallel outside the lens. Yes. Okay. Let's use like a blue line here. So that's coming in. I believe light rays that pass through this is a converging lens, right? Is the first thing a converging lens? Is the objective a converging lens? Oh, they are convergence lenses. They are convergent. Okay, great. So that means it's going to come down and pass right through the objective like that, right? And then the other one you learn, I think, is that anything that goes through the middle of it also just goes straight through, right? And then there's one more. Oh, I didn't draw that correctly. Yeah, there we go, like that. Yeah, okay. And actually, you only need 2 of these. So wait a minute. I think the image formed by the object of the objective is that you have to trace backwards. Right? So now you got like some goofy shit like this. Is that right? I don't know. Is it way out here? No. Something makes me say no. No. Assume all incoming rays are parallel. They flip on the focal point and pass through the second lens, making it parallel again. Okay. But a smaller distance between the rays. Okay. So you're saying that, for instance, like when this one comes in, it's also gonna like pass through like this? Oh, I see what you're saying. Okay. Yeah. Okay, cool. So let me put some other colors like down here. It's like a parabolic mirror. Yeah, I guess so. But then this thing, right, must have a focal point out here. Right? So do they come out? Do they come out this way? Do they come out parallel? I don't think they do, right? Shouldn't they like converge as well, like through this? You think they flip? You're 100% they're parallel out. Okay, cool. So what, they just do this? What's the usefulness then of the focal point of the eyepiece? Hamiltonian dynamics says it depends where the focal point is. All right, let's go look. Let's go look at the... I need to Google something here. Refracting telescope lens diagram. I hate optics. Absolutely hate optics. It's the worst. Okay. So you're all right. They do come out. They do come out parallel like that. The top diagram is what I learned? Yeah, this one over here. Okay. If both lenses have the same focal point. Okay. Do they have the same focal point? No, they don't actually, right? You want to, I guess, find out the focal point of the eyepiece and the objective lens at the same point. Uh-huh. Oh, you want to put. Okay. Okay. Wait one sec. I'm a sophomore in high school doing geometry right now. My teacher says that I do AQR instead. What's AQR? What does that stand for? Okay, so this is kind of what we have. What about this question about, so the extremities of the object. Sure, that's out here. And I agree. When something is so far away, even though the light goes out, in a circular pattern, to someone very far away, it looks like it's coming in just parallel. Yeah. What's up, 23 Pro? Yeah. I guess we kind of like show that, right? Do we have I wonder if there's a cool diagram of that. Radial light looks parallel at big distance. So why did this light stop working? There we go. More like a cool little diagram of it. This is cool. I don't know what advanced quantitative reasoning is. It sounds like some made-up math thing they put for, like, high school people. Big distance should be the new imperial unit. What's up, High Potential? Shout out to High Potential. Congrats on getting your PhD. Excited to see what's next for you. That's always the question, dude. Once you finish your PhD, they're always like, and what's next? It's like, man, I haven't thought that far. I delayed it for like a year or two and just did a postdoc. Oh, Algebra 2 is AQR? Dude, doesn't AQR just sound like some made-up thing? Yeah, it sounds like some made-up thing. That's a made-up course. You had a job lined up, it fell through. Uh-oh. Gonna spend 6 months finishing my non-proliferation work. Wait. Like nuclear non-proliferation? What type of non-proliferation are we talking about? Or non-profit work? And then your advisor saved you some random funding. Nice. Yes. Nuclear. Yeah, nuclear non-proliferation. Okay, cool. I thought you did like space stuff. Aren't you like involved with NASA? What are you doing with like nukes? Oh, detecting if adversaries are doing the no. Yeah. Okay. All right, yeah. Right, because if they are testing nuclear weapons, we would probably see it in the ionosphere or something, right? Recon and stuff. Ooh, sneaky. Very, very sneaky. Cool stuff. High potential. Yeah, my advisor also kind of like saved my ass. When I graduated, I had to get like pec surgery. They had to like reattach some tendons from my arms to my pec, and I was gonna lose my health insurance. No. And so he was like, "I assume you still want health insurance." I'm like, "Yes, please." So he really saved my ass, and he said, "Okay, well, we'll have you work on another paper, and we'll just keep you on the books for at least another year." I was like, "Okay, thank you." Oh yeah. It's really nice. Really nice when people do that. Also, fuck health insurance. It's a scam. There is a lot of potential nukes. Name checks. High Potential's a cool guy. Go check him out. He does kind of like a Truman Show type stream. He's streaming all the time, like 24 hours. And he's always on. It's really cool if you want to like just get an insight into his life. Exactly. It is such, yeah, dude, having the right advice. If I would give the #1 recommendation from anyone going into graduate school, be very careful about who you pick as your advisor, because you're basically getting married for 6 to 7 years. Sometimes less if you're really, really smart or have an easy PhD project. And so how things turn out for you really dependent on the person you picked who's you're funding. So yeah, I got lucky. I had an awesome advisor. Love my advisor. Great dude. His name is Troy Carter. Okay, so this is what I want to talk about. If you have a light source, which in this case is this cute fucking cat playing the banjo, they do emit light in all sorts of angles, right? In a radial pattern, right? Radially symmetric. Which is kind of demonstrated here. Here they're only showing 2 of the light rays, right? They're just showing it like this and this, right? But then what happens as you get further and further away from this cute cat playing the banjo, those light rays start to disperse, okay? And so actually, even though this, for instance, looks like a single light ray, if you were to zoom in like even further beyond, there's technically other ones like above and below it. It's a great fucking diagram, right? The cats playing the banjo actually emit light. I mean, yes, they do. Yes, everything emits light if you can see it, or it reflects light at least. So what you're basically showing though is that as you get further and further away from the cat, stream's freezing. Oh dear. You know that is probably Discord. I'm changing the quality on Discord. Sorry, one sec. You're right. Oh man. Oh dear. Oh, I just got huge frame drops. One sec. Why is that? No. Not today. One sec. Is it just Twitch that's messing up? Wait a second. I think YouTube's fine. Yeah, it's Twitch then. It's gotta be Twitch. Gotta be Twitch. Twitch is messing up. Oh, let's go check things. No, pretty standard. My speed's fine. This is great. Bandwidth is fine. What's up, fam?
Bing bang.
Trying to figure out why Twitch is not working. Give me a second. Even the ad is buffering? Oh dear.
Surprise, motherfucker.
That's sad. Oh man. Is it fine on Discord, Shaq? Yeah, is Twitch getting DDoSed? Yeah, that's a good question. Let me see if other streamers are actually working on Twitch. That's actually that's what I should be checking. Yeah, yeah. So it's not my connection. It's just Twitch. Let me see if anyone else is okay. Yeah, so who knows? Yeah, the other ones are fine, yeah? I'm stealing your bitrate. I don't want to close all of OBS, though. It's such a pain to do that. I don't know what it is, then. Okay, I don't know. My suggestion would be go to YouTube until Twitch decides to figure out what it's doing, because it's the same stream. I'm outputting it on everything. Dude, the CIA, no. One sec, let me try this. I have another way I can do this. I think I can manually stream to Twitch this way. I'm here. What's up, Star? Yeah, no, okay. We're gonna stop this. And then I'm gonna see if I can stream it directly. Sometimes this works. Why is it not horizontal? Because YouTube doesn't like vertical. For the algorithm, it doesn't like YouTube. It doesn't like vertical for the algorithm. I would be okay if Twitch wasn't being a huge pain in the ass today. Okay. Okay. But I think YouTube's still up, right? Is YouTube still up? Okay. I might try doing it in a second. I might try doing
what
Twitch.
Happened?
I don't know. Twitch is being weird. It's crispy clean here. Okay.
Yeah, I was watching it on the stream because I'm on the phone, and then I was like, oh no, like points.
All right. Yeah. Just go to YouTube. All right. Whatever. I don't know. I don't know why it's acting up. All my other platforms are fine. I'll try restarting it. Oh, there is a major spike? Yeah. No one says, I'm thinking about taking Bio 12, Chem 12, and Calc 12 one semester. I've struggled with these subjects in the past because it wasn't really studying. Do you think it's doable? Bio's pretty easy. Chem and Calculus at the same time might be a little bit difficult. But, you can totally take them the same. You can take them, continuously. Yeah. The time, yeah, if you put in the time and effort, you'll be okay. All right, let me finish up this question from StarProd, then we'll go do the next one. Okay, so anyways, the kitty, the banjo kitty that signaled the death of Twitch. No. What I wanted to show is that very close to the source of light, light rays all look like they're radially outwards. But then as you get further and further away, that like center line splits into a bunch of other lines, or like you can see the other smaller ones that were next to it. The light spreads out. So for instance, see how this top line is now way up here and this bottom line is like way down here? Cat Banjo was the harbinger of death, yeah. So, but this center line, which was here, now has a bunch of other little center lines that we can see because we're far enough away, and all of that light is parallel. The platform reaper. No. Yeah. Okay. So yeah, so that's why it's basically parallel coming in. Answering the rest of this question though. Yeah, so I think this is the light rays. The intermediate image, I don't know. I think the intermediate image is here maybe. Then the final image observed in the eyepiece. Star says it would be virtual. Yeah. Cause yeah, what do we see here? In between F and the center. Yeah. So it's virtual bigger. Okay. I can believe that. Oh, not like 3 minutes. I meant like 30 minutes. I'll try it again, actually. Let me just see. Let me see if it decided to fix itself. Oh? Maybe Twitch did fix itself? Looks fine now. Okay, you can go back to Twitch. It's because the Banjo Kitty's gone. We are so back. Okay, there we go. I don't know. Twitch sometimes. Twitch. Okay. Oh, this is cool. I like this too, actually. So objective and eyepiece are at the focus. And then the final image is virtual and inverted. Oh, I see. And you're and you're seeing it like way over here. Okay, cool. All right. Does that kind of explain, I guess, what the question was? Position the exit pupil of the telescope and the observer's eye. I don't know. I guess it's over here, right? This is the eye. I assume it also kind of wants to be at like a focal point though, right? Like this has a focal point over on this side. Okay. Cite the notable difference between the arrangements and the characteristics of the lenses. I guess this one has a has a much bigger focal point than this one. Kind of what we say. Well. Yeah, here you go, yeah. So eyepiece, small aperture, small focal length, and then the objective is a big aperture, so it lets in a lot of light. And then it has a long focal length. Yeah. So it's a higher curvature. Right. Okay, cool. Yeah, so that's what we could say. So this has like low F. So high curvature. And this has a high F. Low curvature. Cool. Okay, I think that's good. I might do the other optics questions you asked later, if we get time. I'm really looking forward to the time, Starry, that you no longer have to deal with optics. Just optics is one of those things I just kind of like, shut up, grin it, and bear it. And I'm just like, I don't really want to do this. I really don't like optics. All right, that was your 6th one. You're done today? Excellent. Love that. Big fan. Okay, so that was... Let's post that. And then here. I'll put the other two, like, in the stream anyways. And then I'll set, actually, I'll set them as unsolved. So that chat can, like, take a look at them later. And I'll put this one in as well. Okay. All right. Twitch is being nice. The world is happy again. Yeah, good luck. Good luck. Yeah, the mirrors and the lenses, that's really rude because they act differently, right? And then a concave mirror is converging, but a concave lens is diverging. Right? And then like a convex lens is converging, but a convex mirror is diverging. Yeah, and the annoying thing is it's all just complete opposites. It's minus signs. It's just carrying pluses and minuses everywhere. Yeah, that's why I really don't like there's no like partial credit for it. Yeah, you have formulas, but then all the conventions. It's like which convention is right? Okay. Two men A and B start with velocities v at the same time from a junction of two roads inclined at 45 degrees to each other. If they travel by different roads, find the rate at which they are being separated. Use that sine of pi over 8 is equal to the square root of 2 minus the square root of 2 all over 2. Okay, cool. This is a related rates question, right? Related rates? Pretty fun. Okay. So we'll say that person A is the red person. Okay. And let's say they're moving this way at some velocity v. And then let's have the blue person be person B. No, you can. No, sorry. I genuinely forgot that time. I usually don't forget, but no, you're right, Star. I did genuinely forget. That's yours. All you did. All you. You're good. All right. And they're inclined at 45 degrees to each other. Okay. And this is also V. Oh, okay. And then we know this is 45 degrees. And we want to know the rate at which they're being separated. So that's going to be kind of, I guess, what this is, right? This is like the separation distance from them. Yeah. Okay, so let's think how that works. Yeah, this is Jeff's favorite thing to do here is like set up a coordinate system. We love a coordinate system. So let's say for person A. So for person A, right? Their position, right, will always be 0 on the y-axis. So you can say that like this will be equal to v times t in the x-coordinate and then 0 in the y-coordinate, right? Good, exactly. Jeff's got it. And then the blue person, that's going to be vt. Why can I not draw things? Okay, there we go. So the amount they go in the x direction is going to be vt cosine of 45 degrees. Oh, wait, actually, let's think about this. Yeah, isn't it vt cosine 45 degrees? And then this will be vt sine of 45 degrees. So I think it's square root of 2 over 2, though. Follow-up question. Pretend they're on a globe and moving in an equal rectangular map. Dude, what the? No. I don't want to do that. Jeff, you ran out of being incorrect this year. You were only allowed to be wrong. That's your mistake for 2027? Are you going to start borrowing forward into the years? Okay, cool. All right, so then this is... so we can say like square root of 2 over 2. And I'm just going to say vt, comma vt. Great. And then we want to... So the distance between them... Distance. That's going to equal to the square root of bx minus ax squared plus by minus ay squared. This is the distance formula between 2 points, right? So, let's see what we get. And then, oh, here's the cool thing. We want the rate at which they're separating. Oh, man. So then we want the separation. We don't want the derivative of this with respect to t. Ew. No. Oh, man. All right, I'm going to call this S. Let's just say, like, S of t. S is just nicer, because otherwise I'm doing, like, dt. Just ugly. Yeah, there's probably a double angle that shows up, Jeff. So let's see. So bx, so that's this, minus this. So that's just going to be the square root of 2 over 2. Vt minus vt. So what is that? So that's vt square root of 2 over 2 minus 1. And then that's all squared. Maybe Jeff, because it's cosine squared. You see how this becomes cosine squared? I think Isn't there an identity for, like, half-angle stuff? No, I need something with, like, cosine squared, though, right? Maybe here, right? Which one did they give us? They gave us the sine of pi over 8. Yeah, I think maybe it's this one. Yeah. But again, we don't really need that because I know what the sine of 45 degrees is. Yeah, I don't know if we can prove that. I think the pi over 8 would eventually come from, I want to say this. Say this one. Because this one and this one, right? But wait, they gave us sine of pi over 8. Oh, not cosine of pi over 8. I don't know, actually. Okay, we'll see. All right, then by minus ay. Okay, so that's just going to be vt squared. Oh, that's actually really smart. I see what Jeff is saying. Jeff is saying, like, oh, well, what if we did this? And we had this was 45 degrees. Yeah, but then this one would, like, only go in this direction, and then this one... Wait, no, actually, yeah, this is actually really ugly. Or I guess maybe it's not. Oh, Jeff, actually, this is really cool, actually. Wait a minute. This is an elegant solution. This is a beautiful example. I wish Narosky were here to see this. Okay. If... It just said they're going 45 degrees from each other, right? So, let's say, for instance, this was going at 22.5 degrees. And then this was going at 22.5 degrees. Then the distance between the 2 points would always be the difference in their y-coordinates. Right? Yeah, that's smart. Yeah. Right, because as this thing goes this way and as this thing goes this way, they're going at... They are dispersing in the y direction at the same rate. Oh... Yeah, sorry. Their x is the same. Sorry. Yeah. Sorry. Yeah, their movement in the x direction is the same, but their movement in the y direction. You don't even need the distance formula. Yeah, you don't even need this. See this right here. This is the Jeff method, and honestly, my method as well. I would have defaulted to doing this way first. I'm just like, cool, 45 degrees, whatever. Let's fucking do it. But this is smarter. This is the smart way. Jeff gets a method. What's up, Zach? So yeah, we had to shut off Twitch for like 5 minutes. I don't know. We're just getting massive lagging issues. Nice. Shout out to Zach. Zach's great. I need to go check out your podcast. I was working out this morning while you guys were doing it. There's the Jeff way, then there's the smart way. Glad my Twitch still works. Okay, cool. Jeff won by a nice solution and then lost for the yeah. No. Forgot the square root of 2 over 2. Okay, alright. So let's do it this way. So then this right here is equal to Vt sine of pi over 8. Right? Cool. So then, and then this is also the same. What's up, Bedlam? So, distance which is equal to s, that's going to equal to 2vt sine of pi over 8. Am I a math teacher? No. I just like doing math. Math's cool. I mean, I tutor a lot of kids in math. Okay. Now, if they want the rate at which they're being separated, so rate is equal to ds dt, right? So, that's just equal to 2v sine of pi over 8, right? Because we assume constant velocity. These are all constants. Dude, this is like a one-liner now. Okay, great. So now this is equal to, with this thing, 2v, and then you say square root of 2 minus the square root of 2 all over 2. 2's cancel. Would the Jeff way have come up with something with a formula that would been way uglier? Yeah. Right. Yeah, I think you could have. So then this is just v square root of 2 minus the square root of 2. Wow. Nice. Cool. Beautiful. Well, they're derivatives, not integrals. Yeah, I think that was really cool. I think the key thing there is that they're traveling the same amount in the x direction. This is why changing your coordinate system, changing your point of view, can be super, super powerful. Because if we were looking at it from our original point of view, doing it this way, it was getting a little tricky, right? I was having to use the distance formula to figure out the distance between here and here, and I had to account for this changing in x and changing in y, and then this changing in x, but then they're changing in x at different rates, and they're also changing in y at different rates. But all we need to know is that they were 45 degrees from each other. So if we moved, symmetry, right? Yeah, we're abusing the shit out of symmetry right now. If you have them move so that the x-axis is directly like the mid-angle between them. What do they call this? It's the angle bisector. Yeah, the x-axis is the angle bisector. Now all of a sudden, this new like x prime or that they're moving in is the same for both of them. So I don't need to account for that. So now all I care about is their y changing for distance. Yeah, it's very cool actually. That's a really cool solution. Thank you, Pi, for that question. Jeff, watch out. You're gonna start borrowing into 2029. Okay, Cassette, you're next. We're gonna do your question. Jeff has allotted himself 1 mistake per year. He gets 1 per year. You're having trouble with the second part? Okay, Cassette, I'll take a look at it. Let me download this real quick. This is a cool solution. I like this one. This was Pi. What's Pi's username? You haven't used 1974. Oh, you get to backdate the mistakes?
Good job.
Are you not counting the day you were born as being a mistake? Okay, let's see. Next one's from Kasey. Nice. I believe we are all eternal souls. I think so too, actually. Jeff, do you think you were like a Roman soldier or something? I think George Patton is famous for that. He swore he was like a Roman general back during the Pyrrhonic Wars or something. I don't know. Okay. The graph shows the variation with distance from the center of a planet of the gravitational potential V. R naught is the radius of the planet. The values of V are not shown for R is less than R naught. Why are there two lines? So wait, we have a line here? And we have a line here? Is it just because that's the derivative, could say? Are you finding the derivative here, maybe? You did the linear line. Okay, that's okay. All right. Oh, I see. Magnitude of the field strength? Yes. Because, yeah. F is equal to negative grad U, right? So, this is... And again, this is just like a fancy derivative for a bunch of different directions. So this is... I think in your case, you did negative DDR of U, right? And yeah, so that would be the derivative of U with respect to R. Fancy multivariable, but yes. It's a fancy derivative. It's one of those fancy derivatives. So this is cool. And then I assume you just found the slope between these two lines. And then we just called it what it is. Which what? Yeah, about minus 3.8. Fancies when you use the script F. What is script F? I don't even know what script F is. I don't... Something like that. I forget my cursive. Yeah, so I think this one... Yo, what's up, Zach? So, Eric, do you also like Has Been Hotel? I just started watching it this week. Shout out to Eric. Eric's an awesome person. Okay. I would avoid calculus and the gradient. Yeah, I just like, well, in physics, right? You do learn this in physics. I think, even in high school. V equals negative GM over R. I use group world. It's called group world. This is IB physics. Zach, does Zach know real analysis? I think he does. Zach, do you know real analysis? I'm pretty sure you do. Oh, this F. Yeah. What's all this stuff? That is a fancy F. Or is it? Oh. It's just at some point. Okay. Yes, River. Zach does know real analysis. You say he does. Okay. So you just did 3.8 times 10 to the 7 divided by 0.5 to the 10 to the 7. So shouldn't that be 7.6? Could say? Yeah, 7.6. Okay, great. Yep. Good. Okay, so let's look at this one. A satellite of mass 3.2 is launched from the surface of the planet. Use the graph to determine the minimum launch speed that the satellite must have in order to reach a height 2 times 10 to the 7 above the surface of the planet. Okay. So this is conservation of energy, could say. Oh, okay, cool. Dude, Zach's giving us all the curled Fs. Yes! Yeah, there we go. Yeah. That's right. This is from music. That's what Jeff was talking about earlier. Okay, so this says that kinetic energy plus potential energy must be constant. Okay. So, at the surface, it's going to have some launch speed. So kinetic energy is equal to 1/2 mv squared, which in this case is 1/2 times 3.2 times 10 to the 3 times v squared. And then let's figure out what UE is at the surface. So at the surface, so they said R naught is equal to 5 times 10 to the 6. So that's right here, right? Okay, cool. I see why they say the graph starts here. Yeah. Does this make sense, Kasey? That this point right here is the potential of it on the surface. Okay, cool. Good. All right. So that's going to be equal to, it is technically negative, but that's okay because potential is going to get higher, so that's fine. So negative 3.8 times 10 to the 7th, right? 10 to the 7th. Okay. Okay, so that's at the surface. And then we want to know at 2 times 10 to the 7th in the air. Okay, so the minimum launch speed would mean that all of this kinetic energy gets converted into potential energy. So this is what I always call like kind of the bank of things, right? Let's pretend like this is kinetic energy and then this is potential energy. So as you start to gain more potential energy because you're going, in this case, higher, right? You're going further away from the planet. Because these two have to add up to the same number, you're going to start dropping kinetic energy. And that's why objects get slower when you throw them upwards, right? Because they're converting kinetic energy into potential energy. If you want to know the minimum kinetic energy required to, let's say, get to some spots, so in this case like 2 times 10 to the 7th, right? Then you want this to be as low as possible starting off, right? So that after launch this goes to 0 and this comes up to 2 times 10 to the 7, but that equals what your starting energy was, your starting total energy. If you start out with, for instance, a ton of kinetic energy, let's say you're just launching this thing like a missile into the air, then as this thing climbs up in height, you're not going to drop all of your kinetic energy. You're still going to have some left over, which means that the object will still be going upwards. So this is like an excessive amount of kinetic energy. You didn't need this much to get there. It's like overkill. So the minimum amount is such that in the final state you have 0 kinetic energy. So for minimum KE initial, maybe, you would say that now KE is equal to 0. And then UE is going to equal, well, okay, what's the potential at 2 times 10 to the 7? Potential at 2 times 10 to the 7 is negative 1 times 10 to the 7. Okay, does that make sense so far, Kasey? That's clear? Great. Okay, cool. All right, so now you just set them equal to each other because total energy is constant, right? So this is going to be, so 1/2 times 3.2 is 1.6. So I'm going to say 1.6 times 10 to the 3 v squared minus 3.8 times 10 to the 7 is equal to negative 1 times 10 to the 7. Okay? Yeah, so you're setting, well, not quite. You're setting the sum of the kinetic energy and the potential energy at the surface equal to the potential energy once it's in the air. So if I wanted to make like equivalent graphs of this, let's see what this is, right? For instance, this would be like on the surface, right? Where this is, what would we say this was? Negative 3.8 times 10 to the 7. And then this potential is different. Sorry, this potential is negative 1. Yeah, I know the minuses are screwing you up. No, they define. They're defining the potential at infinity to be 0. That's what they're doing. Do you see how this asymptotically does this? So they're saying that like at infinity v equals 0. Yeah. You remember this? Yeah, cool. I know it looks weird. The minuses are weird, but the key thing here is that potential is going up because it's going from like -4 to -1. That's technically an increase. So this is what's happening. You have kinetic, you have some potential, and then afterwards you've dropped all your potential, all your kinetic, sorry, and you've dumped it into potential. And so that's why we're setting them equal to each other like this. Yeah? Let me get my, where's my calculator? Calculator, where'd you go? Calculator. Oh, did you just stop working today, calculator? The hell? Oh, there it is. Found it. Yeah, I know the minus sign can be tricky for sure. But anytime we're doing things with energy, it's the relative change that we really care about. It's not the absolutes. Okay, so in order to solve for this, right? You can very easily, just move this over first. So that's going to be 2.8 times 10 to the 7. And then we're going to divide that by this. So 1.6 times 10 to the 3. And this is all going to equal v squared. So then v is equal to... so 2.8. E to the 7 divided by 1.6. E to the 3. And that gets us that. And then we're going to square root it. And so, yeah, you get 132.3 meters per second, which actually isn't that fast. So wait, I think like 23 meters per second is 60 miles an hour. So this is like 360 miles an hour. Maybe 400 miles an hour. It's not very fast. Seems kind of low, right? Did we do that right? I think we did, right? Yeah. Yeah, it's only 300 miles an hour. They got 7.7. That sounds better. One sec. Yeah, so yeah, let's see what your friend did. Let's see if I can poke some holes on it. This is one way to do it. They're saying that changing kinetic energy is equal to change in potential energy. It's technically correct. I think this makes more sense to me. To think about that the total energy has to be constant. And to look at what the different components of the energies are before and afterwards. Interesting. He says M delta V. Oh. Uh-huh.
Oh, yeah.
Yeah, here's the key thing here. Sorry, this potential is not in joules. It's in joules over kilograms. So you do need to multiply by the mass. Interesting. Okay. Sorry. Yep, got it. Okay. So this is times mass. And then this is times mass. Does that make sense? I assume this potential was given in just joules. It's not. It's given in joules per kilogram. So you have to multiply the potential by the mass in order to get it. Which, all good. Yeah, I know where you got it. Yeah, I'll show it to you. Where do you get the minus 0.8? Minus 0.8, I think, is what you got from minus 1. Because, wait, it said when it reaches a height of 2 times 10 to the 7. 2 times 10 to the 7... Oh. No. I was wrong. Sorry, it's 2 times 10 to the 7 above the surface. And the surface is already half, right? 0.5 times 10 to the, right? So 2 above the surface is actually here. Oh, that's actually really tricky. I didn't even think about that. Yeah. You know, your friend's right, actually. So you want to do this at minus 0.8. Interesting. Okay, fine. It's okay. It's not the worst thing. Last time I checked, it was 1 kilogram per family joule, but your measurements 1 kilogram per. Yeah, base friend. Yeah, your friend's pretty good. I feel like they're just memorizing a formula, though. They're not really internalizing why this is. Yeah, okay, for sure. Okay. So, again, 2 situations. You're on the ground. You're some distance in the air. You need to know what the potential energy is when you're in the air. And they said you're 2 times 10 to the 7 above the surface. So imagine this is planet, right? And this is R naught. They want to know when you're 2.7 above the surface. The surface is 0.5. Or sorry, they want to know when you're 2 above the surface. Sorry, not 2.7. I don't know where I was getting 2.7 from. Sorry, 2 times 10 to the 7. That's where the 2.7 is. So when you're looking for what the potential energy is when it's in the air, you're not looking for when R is equal to 2. You're looking for when R is equal to 2.5. Because R is measured from the center of the planet. So when you're figuring out the potential energy, when it's 2 times 10 to the 7 in the air, you're actually finding the potential when it's at 2.5 in the air. Where it's 2.5 from the center. And that corresponds to a potential energy of negative 0.8. So, yeah, 2 errors here. First of all, yeah, this needs to be negative 0.8. And then also, when we're calculating the potential energy, you need to multiply by m on both of these. So, here, let's... Yeah, because I thought that was weird. I was like, wait, 132 meters per second? That's not very fast. That doesn't make any sense to me. Okay, so here we go. So, this now becomes 1/2 m v squared. So, this is like v naught squared, right? Is equal to... and then plus negative 3.8 times 10 to the 7 times m is equal to 0 plus negative 0.8 times 10 to the 7 times m. You get it? All right, cool. So then what you do, right, cancel the m's because there's m's in every single term. you move this over. That's where you'll see this. When we move this over, this is the same thing as delta potential energy, which is what your friend did here. He called it V grav, because you're subtracting the potential energy from the final and the initial. So negative 3.8 plus 0.8, that's just going to get you negative 3. Or no, it's just going to get you 3, sorry. So 3 times 10 to the 7 is equal to 1/2 V naught squared. So V naught is equal to 6 times 10 to the 7. V naught squared, sorry. So then, yeah, square root that. And now you get 7745 meters per second. Yeah. Which, yeah, that's the same answer he got. He got like 7.7 times 10 to the 3. Cool. All right. Does that make sense, Kasei? Yes. Awesome. Good. Great. Glad you got it. Sweet. All right, another question done. Again, if you're watching us, make sure go join our Discord, because every time I do a question, it's going to get added to our Discord server here. So here we're going to mark Kasei's as done. You are next. You are next. I'm going to try to help you, River. I might need Zach's help, honestly. But that will get put into a little channel here, and then I'm going to dump the solution here for Kasei so that Kasei can see it. And then Kasei also earns a bond coin in our server for asking a question. So there you go. There's your first one. Or maybe not your first one. Maybe you redeemed earlier, but yeah. Okay. Power series coming up. You know the solution, you just want to know the proof? Okay. This is series. This is Zach's favorite. Zach loves series. Let's go, dude. Yeah, Zach loves it. All right. We know that 1 over 3 plus 1/3 x squared is equal to 1/3 minus 1 over 27x squared, blah, 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 blah. Okay, cool. For x is in the radius between -3 and 3. Using this fact, find the function that corresponds to the following series. Okay. Just integrate the original series. Yeah, okay, cool. Wow. Uh-huh. $20-30 mistake already. Oh, man. Yeah. So, yeah, the proof here, River, right, is if we know this is equal to this, let's just integrate both sides. Right, so if I integrate this side, just look at it like term by term. This is the common thing we do in series. You look at like each term, right? If I integrate each one of these terms, this would become 1/3 x. This one becomes minus 1 over 27 3 x to the third, which is the same thing as 1 over 81. And then this one, yeah, becomes, yeah, plus 1 over 1215 x to the fifth. Oh, that's what you don't get? Okay, well, this is easy. All right, so now we do this. So because we took the integral of that, we need to take the integral of the left-hand side as well. Okay. So all we're doing is taking the integral of 1 over 3 plus 1/3 x squared dx. So, a clever substitution here. I think what I want to do. I think Yeah. Ooh. Oh no. Zach has a mistake too. Mistakes are coming in, dude. They're coming in. All right. Let's multiply both sides. I want to see if I can show without. I know there's a memorization for the integral of arctan, but let's see if we can do it without doing that. Right? I think I can. Yeah. Zach mistake equals -1 Jeff mistakes. He's redeemed. Okay. I think I want to multiply the top and bottom by 3. I think I just want to do that, right? So I have 3 integral of 1 over 9 plus x squared dx, right? And then I'm going to say let x equal 3 tangent squared, 3 tangent of x, or 3 tangent of theta. I think that helps me, right? So dx is then equal to 3 secant squared of theta, right? Okay, so now when we substitute that in, you get 3 integral of 1 over 9. This becomes plus 9 tangent squared theta. And then this is times... Yeah, I don't really know my integration ddx trig rules. Yeah, so let's just do it. I'll show you like where it comes from. Yes. I know it's just arctan, but I want to show why it's arctan. I think it would be cool. Why is that substitution allowed? You can substitute in whatever you want. I could have said let x equal like 69,420x or like whatever. It's convenient because what we notice here, and here there's kind of like a cool little table. Math is all about recognizing patterns. There's a lot of pattern recognition. Why do you like indefinite integrals? They're ass. So, this is whenever you see the square roots. We'll have to see if this one plays out. But in general, anytime you see like a squared plus x squared, it's nice to like substitute x as a tan theta, because then you end up using this trig identity to make things nice. Why are the math guys making mistakes?
Oh shit, not good.
Okay. So here, I'm just doing this so far, okay? So, this is just a convenient substitution. And the reason why we make the substitution is that because I know that 1 plus tangent squared is equal to secant squared. And that's what we're going to get here on the bottom. Okay, so the 3 and the 3 combine. So now I have 9 over, and then I'm going to pull a 9 out of the bottom here, right? And then that's integral of secant squared theta, d theta, over 1 plus tangent squared theta. Okay, here's the cool thing, right? 1 plus tangent squared of theta is literally just secant squared. So now this is 1 integral of secant squared theta, d theta, over secant squared theta. This cancels. And so this is just the integral of d theta. But the integral of d theta is just theta. Yeah? Okay, cool. So our original integral, though, however, had nothing to do with theta. So we need to go back to what our substitution was to figure out what this answer is in terms of x. So now I'm going to take this. I'm going to say, oh, but x is equal to 3 tangent of theta. So that means when I move this over, that x over 3 is equal to tangent of theta. Or, if I take the arctangent of both sides, you're going to get that tangent -1 of x over 3 is equal to theta. And then that was your answer. Does that make sense, River? Oh, you forgot -1 is the same as... Yeah. This is also... Yeah, the reason we say that is because some students then think this is like 1 over tangent of x over 3.
You're not that guy, pal. Trust me. You're not that guy.
And it's not that one. Yeah. The -1 implies inverse. So you could also say, or arctan of x over 3. Nice, cool. Good question, River. I like that one. That's fun. You're very welcome. More than happy to answer fun calculus questions. And for you guys to learn stuff. I love that. All right, cool. That was River. All right, cool. Nice. Good job, River. All right, let's see. What have you guys been talking about in chat? E equals 3 equals pi. It's a pretty great one. I don't knock it. All right. Ooh, wow. All right, Blue. We're talking about invasive fish. Okay. Yttrium einsteinium. Oh, I see. Yeah. You guys are using All right, let's see. Biologists found the population of 2 invasive fish species in a large lake was changing exponentially after the lake was first surveyed. Here are the graphs showing the growth of each fish. Cool. Right. So, good. Got some good stuff here, right? Yeah, this one starts at 5,000, and after 2 years is already at 20,000. Wow. So, if you were to model this as an exponential function, why are we doing biology? It's technically math. This is like the only math that biology really looks at for the first year or two. Nightbot spitting. Biology is math, science is math, life is math. So yeah, so in this case, you're right? This is doubling every year, right? 5 goes to 10, 10 goes to 20. So you know R is equal to 2. So sometimes it helps just to write out what the equation would be. So you know that A is equal to A naught RT. R to the T, sorry. So in this case, A is equal to the initial, which is 5,000. And then you'd say, and the rate is 2 to the T. What's up, Moink? Moinak. Nicholas Menton Kinetics. Is that what this is called? Okay, this... Well, it's kind of hard to see where it goes. I guess it starts at... Do you want to say 1,000? I think that's probably 1,000. Yeah, right? Yeah, let's say it's 1,000. And then it goes to 3,000. So good. So yeah, you wrote that well. Okay, good. So that equation would be that B is equal to 1,000 times 3... I'm just saying random shit. I appreciate the random shit. Okay. So which one was... Oh, what? TikTok just decided to dump everything in the chat. What are you doing, TikTok? Okay. So... Clausius Clapperon. Yeah. Klaus got clapperoned.
Surprise, motherfucker.
Okay. Which one was biggest when it first surveyed? Yeah, that's obviously this one. That's the one that started. Okay, I think you got all this. So maybe let's like look at this one. Describe the domain of each function. What does the domain mean in this situation? What are the restrictions of the domain? So in the first function, I mean, I think the domain here is just from like 0 to infinity, no? Because this arrow means that it keeps going. I mean, yeah, I get it. I would say that like 0 to infinity for both. What does the domain mean, right? So because the earliest time is at t equals 0, right? Which is the beginning. The furthest time is infinity. Yeah, meteorology is not this. It's unfortunate. Furthest time is infinity, right? Because I assume these fish just like, well, they don't live forever, but the lake does. Okay. Range refers to, and so domain refers to the time, right? So range refers to the population. So for population A, right? The lowest population is 5,000 and the greatest one is infinity. All right, so this one would be 5,000 to infinity. And then this one would be 1,000. No, you don't have to say a whole paragraph, no. And it just represents, so this represents the time, and this represents like the number of fish. Which, you know, assuming you can't go backwards in time. Right. Is the domain really starting at 0, though? Yeah, I mean... Okay, so technically the domains for the function is... Yeah, this is kind of weird. Okay, fine. Because the restrictions of the domain is greater than 0. Okay, so maybe that's what we should write. Sorry. Okay, let's do that. Psycode has it better. Okay, all right, so domain of function is technically negative infinity to infinity, but the restriction is that t is greater than or equal to 0. And you could say, like, because we can't go backwards in time. Like, you can't have negative time. Okay, so then technically the range of the function is 0 to infinity for both of them. Because this function does trend down towards y equals 0, but it's at negative times. So this would be 0 to infinity. 0 to infinity. And then what are the restrictions that arise? So you could say, like, assuming no negative time. This one would then become 5,000 to infinity. No, range is the number of fish, but we're assuming that you can only measure the number of fish when time is greater than 0. So in population A, that means the population of fish can be from 5,000 up to infinity. And then for population B, it can go from 1,000 up to infinity. Does that make sense? Yeah? No, you're good. Complete the phrase. As each year x increases, the value of f of x... I don't know. Well, is f like a certain one? No, they just say it doubles for a. Doubles for A, triples for C. Oh, the value increase. Oh, you can just say increases? Okay, sure. That's all it is. Okay, fine, sure. Explain how you know. I don't know, the function's always going up. You could say that the slope of the functions are always positive. That's one way to say it. Yeah, I don't think he needs to find the derivative because this is actually kind of a complicated derivative. Number go... yeah. Slope refers to this, right? You see how the slope of that is always like going up? And so the slope is always positive. Yeah. Okay, for each fish population, write an equation that relates it. Okay, so we already did that. That was these. Yeah. Create your own characteristics. Calculate, compare, do what? What? Your own characteristics? I don't know what this means. I guess you could say that B will eventually overtake A. Because it triples versus doubling. Just get out. Get out! Iodine, carbon, potassium, yttrium, ICPY. Icky. Okay, if you wanted to figure out when that was, you could actually do that this way. Let's say, for instance, you wanted to figure out at what year they equal. Because this would be pretty cool. You could just set them equal to each other. So 5,000, 2 to the t, is equal to 1,000, 3 to the t. So then if you wanted to solve for this, right, divide this over. So you get 5,000 over 1,000 is equal to 3 to the t over 2 to the t. This is the same thing as 3 halves all to the t. And then you set this is now 5. So 5 is equal to 3 halves all to the t. If you want to solve for this is a math trick. Anytime you have a variable that's up in the exponent, if you want to pull that variable down, just take the log of each side. Have you learned log rules yet, Blue? No? Okay. Well, I'm going to teach them to you. But, okay, here we go. So, EX log rules. The one rule we're using here is like the ln of a to the b is the same thing as b times the ln of a. Because now, this thing's going to come down. So you're going to have ln of 5 is equal to t, ln of 3 halves. And now you just move this over. And so you get ln of 5 over ln of 3 halves is equal to t. This you need a calculator for. Because I don't know what these things are off the top of my head. So ln of 5 divided by the ln of 3 halves. And that gets us 3.97. years. Okay. So if you wanted to, you know, go the extra mile and show your teacher you're really smart, just say that at t equals 3.9 years. Approximately. Yes, approximately. Thank you. About. There we go. That's the correct term. So cool. That's what you can tell your teacher. Then if you showed him this, be like, ooh, big smart person. Okay. Do you guys want me to do this? Damn it. Like that? There you go. Fine. Cool. Based. Nice. Great. Awesome. Love. You will do it when you finish the 3-month resolution. Yes, thank you for all filling that out. I'm really proud of you guys. We had like 15, 16 people. You guys filled the actual resolutions, which is dope.
That's dope.
I will send something over the weekend to each of your DMs about like what you put in and what you want to do in the first month, so you can kind of like set it as like a little target. Oh, it's about you getting smarter? That's dope, dude.
That's dope.
Getting smarter will help you out. It's the same thing as like getting stronger at the gym, you know? Just work on yourself, king, or whatever. That's what they say. Nice things will happen to you. Nice people want to hang out with you. You'll get a nice job. Can't guarantee you'll get the house and the family, but, you know, you at least increase your odds. 3.97 is around 4, 5, or 6 for approximate error tolerance. All right, cool. Let's see what we got on the queue. Easy, easy. Oh, Jesus. Okay, cool. This looks fun. Let me give you a bond coin. Blue. Good job. The house joke was personal. The house always wins. Okay, let's see. This looks like some... Alright, later, dude. Thanks for coming by, Blue. Determine the magnitude of the force F that must act on the right body so that the left body does not slip down the inclined plane. Given mu mu... I think you're just given mu in this case. M, and you're given A? I'm assuming A is the angle. There's a couple things that are like kind of wrong with this question, first off. Like what? Static friction is the first given. Oh. A is alpha. Thank you, Effie. Okay. So you're saying mu S, mu K, M, and alpha. I think we need alpha because I need this. I need that to solve. I don't know why this says mu H. It's a weird one. Okay. And then what we're saying is... Also, I don't know what's going on here. If it's a massless rope, we assume there's no friction. So I don't know why they wrote mu H here. Right? That doesn't make any sense, right? Right? In order for their given mu mu, I know, JC. Okay. All right, let's draw some force diagrams. Okay, let's look at this one first. So, first one has a mass M, and then we're given a force F. Yeah, you don't need kinetic, right? Yeah, because we want... I think we want to know the minimum force. I mean, if you wanted to be cheeky, right? You could say that F is just equal to, like, 1 times 10 to the 6. Newtons. You could say it's just fucking huge. And then, yes, of course, the left body will not slip. I assume they're asking for, like, what's the minimum force, right? Yeah. So, yeah, this is going to have a force F. And then it's going to have a tension that's pulling it back. And then also, I think we're going to assume that friction is preventing this thing from falling down to the left. So we're also going to put here force of static friction. Fs, okay. Okay, and then let's look at this one. Alistair says, "Can you help me understand how momentum is the integral of force?" That doesn't sit right. So P equals mv. Does that make sense? And then F is equal to ma, which F is equal to m dv dt. So integral of F dt is integral of m dv, which is equal to mv, right? And so that's why the integral, and then this is the same thing as p, right? Yeah. Cool. All right. Okay, so this m now. Oh, and also there's a normal force. Sorry, I forgot about all these forces. Sorry. There's force gravity. And there's a force normal. All right, looking at this one. So this is going to have gravity pointing straight down, but if I like rotate my axis, it looks like it's down and to the left. So this is force gravity, where this angle here is equal to alpha. This equals alpha because, I don't know, this just makes it like a bunch of right triangles and eventually works. You're welcome, dude. And then this is force normal. And then you're going to have the tension in the rope pulling it to the right. And then I assume friction is also, again, trying to help me here. By pulling this, by preventing this from falling down. Yeah. Okay, so right off the bat from here. Well, yeah, sorry, it's the integral of Yeah, work depends on, work is F dx. Which is the same thing as it's the same thing as velocity times force. Yeah, well, no, sorry, force times velocity is power. Okay, so looking here, okay, and then Fs here is equal to, we're going to say mu, and then here, Fg here is just equal to mg. So this will be equal to mu Fn, which is equal to mu mg. All right. So, looking at the sum of the forces in the x direction here, you get that F plus mu mg is equal to T. Okay. And then let's look here for like what tension would be. The integral of speed gives position. Kind of. Integral of velocity gives you displacement, which is the change in position. Yeah, there you go. Yeah, okay, cool. All right, so then here, you can then split this one into, this is going to be Fg cosine alpha. So that's going to be mg cosine alpha. And then this is going to be Fg sine alpha. which is equal to mg sine alpha. Okay, so that tells me that the normal force has to be equal to mg cosine alpha, because I need the sum of the forces in this direction to be 0. So now looking at just sum of forces in the x direction. And again, this is also going to be mu s Fn. So that's going to be equal to mu s mg cosine alpha. Here you're going to have t plus mu s mg cosine alpha. And then minus mg sine alpha. Okay. Or, sorry, must equal this. Yeah, sorry. You want the sum of the forces to equal to 0. So all the right forces, which are here, have to equal all the left forces. Okay, cool. So then t equals this minus this. And then we can plug that into here to go get f, right? Because from here, you have f is equal to t minus mu mg. And I assume, we assume all the mu's are mu s's. We assume it's static. Hasn't started moving. Okay, cool. So, this goes over here. And you should just get this. F equals... Let's see if we can, like, clean things up. I can pull an mg out of everything, right? So I'm going to say mg. And that's going to be sine alpha minus mu s cosine alpha. And then I'm going to say minus mu s. There you go. Okay, cool. That is your final answer. Nice.
Good job.
Now, one thing you can do to check Fe, just to make sure things are correct, consider if alpha was equal to 0 degrees, right? So let's consider that these two things are on the same inclined plane, right? In physics, we call this like checking the extremes. So like, let's check if alpha was equal to 0 so that they're flat. If alpha was equal to 0, sine of alpha is 0. Cosine of alpha is 1. So then you get negative mu s minus mu s. So what would you get there? You would just get F is equal to negative 2 mu s mg. And I guess that makes sense, because all you're doing at that point is you're overcoming the friction of both blocks, which on each block it's mu s Fn. So mu s Fn, and then there's 2 of them. Don't really worry about the minus sign. Don't worry about the minus sign. Just get rid of it later. Right, yeah, okay, cool. So F is equal to 2 mu s mg. Okay, but let's also check if alpha was equal to 90. Okay? If alpha is equal to 90 degrees, right? Now this thing is just hanging straight off of this, right? So in this case, this one goes to 0. And now all you're left with is and then this becomes 1. So then you would get F is equal to mg minus mu s mg. And that should make sense, because you need to pull the force of gravity that's pulling this thing down but you're getting help because friction is giving you mu SMG to prevent this thing from like totally falling. So, yeah, this makes sense. Cool. All right, cool. Good question, Effie. Effie, if you want the answer for that, yeah, I'll post it in our Discord. Make sure to go join. Effie. All right, nice. How are you guys doing, chat? What's up? We're talking about integrating like displacement and velocities and stuff. Those are always cool. Distance and displacement is always a fun difference that I love teaching people. So Zach, you were teaching or not teaching, you were developing like differential equations stuff, I think on Tuesday. And you were talking about damped oscillators as like a cool physical representation of like why diffie-q is fun, at least in physics. And yeah, and that kind of connects back to what damped but then the other cool thing is like damped driven oscillators. So then you have like 3 terms. Yeah, they're cool. I think they are a great way to show how you can have multiple derivatives inside of something. Get damped, Zach. Buildings are just oscillators and others and in other engineers' opinions. Oh man, y'all choosing violence this morning. Alright, let's see what we got. Pie's got another one. Ooh, this is a fun one. You guys are gonna have some fun with this. Find the derivative of y is equal to 1 minus x times 2 minus x all the way to n minus x at x equals 1. Yo, what? What is this? Yeah, dude. I can keep spinning it. You want me to spin it? I can spin it more. I think this is like approximately straight, yeah. Okay, this is one of these things, right? Y is equal to, you guys have like this fancy one like this, right? And then this is n equals 1, or I'd say like, sorry, a equals 1 to n, and then this would be 1 minus a. Yeah, Tony Hawk, yeah. Let's see if he wants to do it. How do you do derivatives? I know how to do derivatives on the addition sums. How do you do it on the multiplying sums? Oh, that's cool, Psycode. Yeah, a lot of things in life are oscillators. I think it's really cool that electronics are also oscillators, right? So when you have like resistor, capacitor, inductor circuits, RLCs are dope. You can do this by induction. Inductively apply the product rule. Yeah. Take a look. Send me a link. I'll check it out. Okay, so inductively. Wait, but this is at x equals 1. Oh, you have a website? Oh, let's go check his website out. One sec. Psycho, I didn't know you actually have a website. Oh, dude, this is sick. Is this like some Node.js shit going on right here? What is this? Yo, what? How are they running this inside of HTML, dude? What? Now let's turn that shit up. Oh
yeah.
Oh, dude, what? Wait, can I just like, I can create waves? Let's go to Ultra. Very beautiful. That's pretty sick. Oh, I see. What if I want to change my colors? Ooh. Oh, this is fun. Yeah, there we go. Now we just got gold dust. Yeah, it's pretty sick. Cool. Oh, I see. Oh, look at that. Oh, you can make waves. Oh, what? New intro screen? Dude, this would be so fun to just play with. Yeah. Sphere radius? Oh, you can make them really big. Oh, this is so cool, dude. This is definitely... Dude, I want to go check out your repo. What? Yeah, wait. How does this work? Wow. Okay, cool. I'll check this out. This is really... You did this 7... Whoa! Wait. You did this 7 years ago? That's impressive. I thought you just vibe coded this like last week. Because I feel like that's what everyone's doing on Instagram these days. Is they're just vibe coding this type of stuff. The fact that you actually like created this by hand without AI, this is really cool, man. I'm a big fan of this. This is cool. Sick.
That's dope.
Yeah, that's dope. That's hella dope. Okay, cool. You don't vibe code at all? You avoid AI? Wow. You and Zach would get along. I vibe code a lot of things. Mainly because I just don't have time. Yes. Yeah, y'all. Very cool though, Psycode. I like that. Okay, maybe inductively. So what do? We show for the base case for like n equals 2, right? Write your product properly. Write your product Say that 4 times fast, right? This will take ages. Yali says, can you go inverse functions? Yeah, Yali, if you want to submit a screenshot of an inverse function question you want me to do, there's a website in there, actualofficehours.com. I can, just because inverse functions is a very big topic, I don't know exactly what type of thing you need to know about inverse functions. But if you drop me an example of one of your questions, like just take a picture with your phone or something, like a homework question or a test question, and put it into that website, I'll be able to know really quickly like what level you're at. I can teach you it. Okay. I feel like I have to do it for inductively, no, right? So what? So y would be equal to 1 minus x times 2 minus x, and so dy dx would be equal to the derivative of the first one, which is just -1, times the second, plus the derivative of the second one, which is -1, times the first. So what does that get you? Oh, and then you evaluate it at x equals 1. So then this one goes away. My pi formula is wrong. This is right. Oh, it's a minus x. Oh yeah, my bad. Yeah. Yeah. Yes, thank you. Thank you. There you go. Got you. Does anyone have any good like mass spec parallel plate questions that are challenging? Ooh. There should be a bunch in your textbook, no? Do you have a textbook, Gladiator, for your class? I want to ask how the Laplacian is the approximation of curvature. Wow. Ooh. The Laplacian is that second, that's that nabla squared, right? Isn't this like the Laplacian? This is the Laplacian, I think. Okay, let me see what this would be. So, and then if you plug in x equals 1, you just then get -1, 2 minus 1. Cool. Which would then be just -1, right? Oh, if you want a harder textbook, I can definitely give you one, Gladiator. Okay. I like John Coley. John Coley has a lot of good questions in it. Yes, I agree. I've seen this as the Laplacian, yeah. I think the first one is mostly, that's the more conventional one. Okay, so then what was this? This was just -1 n minus 1. Do I then show for like a higher level one what it becomes? Maybe like n equals 3? So this is where things get weird, right? Because it's the derivative of this one. Oh, it just starts becoming like nastier, right? So this becomes -1 times, right? 2 minus x, 3 minus x, and then plus 1 minus x times, times the other stuff. But this will always be 0. Uh-huh. Oh, I think I see it. So no matter, right, no matter how big this thing becomes, let's say whatever, it becomes like 4 minus x, 5 minus x, blah, 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 blah. Whenever you do the product rule, you always take the derivative of the first thing, which in that case, that would just become -1 times all this. So this would be your 2 minus x, 3 minus x, 4 minus x, ... And then you add it to the first thing times the derivative of the second thing. So this is your 1 minus x times ddx of this whole mess. But then the cool thing is, when you plug in this goes away.
Bruh.
Okay, cool. So so this is the only thing that survives. And so it's just -1 and then let's see what happens. This becomes 1 times 2 times 3 times n minus 1, right? All the way times n minus 1. Okay. So I think it's just -1 times n minus 1 factorial. Thanks, iCode. Sweet dreams. So I think that's it, right? It's -1 times n minus 1 factorial. I'm gonna say it is. Cool. Cool question.
Well done! Well done!
All right, Yali, I see you submitted a question, Yali, and you are a new user, so I will give you a little bit of preference, and I'll do yours real quick, and then Kempy, I'll do yours. I appreciate Kempy you asking a question as well. Yeah, Riemann sums, totally. I can totally do this. Let me see what Yali has real quick. Just because they're new. And I know people on TikTok are like, there's no way this is real.
Surprise, motherfucker.
There's no way this guy's actually going to help me. Yeah. Okay, let's see. Okay. So maybe help me out, Yali. Are they asking you to find the inverse of these functions, or is this kind of the stuff? Okay, cool. All right. So finding inverses are not too hard. So what I like to do is I like to replace this thing and just call this like y. And then you have this. You have 2x plus 5 over 3x minus 4. We're going to go back to this. We'll put it back in a second. Or at the end. And then all you have to do is swap. So anywhere there was an x, those things become y's. And anytime there's a y, that becomes x. So now this is x is equal to 2y plus 5. Over 3y minus 4. Cool. Alright, I want my colors to look the same. Okay. Now your job is to try to solve for y here. Yeah, you just switch them. This is a little tricky though, honestly. Because my gut instinct is to like move this over here. So I'm gonna like multiply this all on this side. So that's gonna give me 3xy minus 4x is equal to 2y plus 5, right? If I take this and I multiply it all over here. So now what I want to do is I want to try to put all the y stuff on one side and everything else that's not y like on the other side. So I'm going to take this, I'm going to move it over. So that's going to be 3xy minus 2y. And then I'm going to take this and put it over on the right. Yeah, you can sub it out. Yeah, put it in. Whatever you want, dude. You're good. You're good. You're good, bro. Let me get rid of this. So this is equal to 4x plus 5. Okay. Now, in order to get y alone, you want to factor it out. Exactly. Alistair's right here. You want to factor out the y. So here, I'm going to like put it up here. So I can factor a y out. And that's going to leave me 3x minus 2 as what's left. And then this is equal to 4x plus 5. And then final step is just to divide that over. And so you get y is equal to 4x plus 5 over 3x minus 2. And then you're almost done. Just one little trick here. The last thing you need to do so that you don't like lose points is replace this y with f negative 1x, or f inverse of x. And then this is equal to 4x plus 5 over 3x minus 2. Yeah, make sure you put the minus 1. That's what denotes that it's an inverse. Okay. Does that process make sense? Yeah. Okay. All right, let's look at this one. This is fun. Said if f of x is equal to 2x plus 3, find f inverse of 2 using only f of x. Okay. So here's how like functions and inverse functions work, okay? So if you have f of x, what that means is you plug in x and it gives you y. F inverse of whatever, or actually, I shouldn't put x here. Let's just say, like, of something. Means you would, like, plug in y, and it would get you back what x was. This is how I like to visualize it. Like, inverse functions do the inverse thing, so they do, like, the backwards thing. So, for instance, this right here, f inverse of 2, is saying... So here, f inverse of 2 is saying, if I plug in 2 for y, what do I get out for x? And so looking here, right, this is your function. That means I want to know what value of x creates y is equal to 2. Maybe, and this also kind of like helps here. Write this whole thing as y equals 2x plus 3. Okay. So now, you have that, like, 2 is equal to 2x plus 3. And you can solve for x. So, minus 3 means you get negative 1 is equal to 2x. So, x is equal to negative 1/2. And remember, f inverse of x gives... f inverse of something gives you the x value. So, you can say that f inverse of 2 is equal to negative 1/2. This is, like, the correct final way to write it. I use Suno, Alistair. And that is the answer. Yeah. Let me explain it another way, because this is kind of, like, confusing sometimes. Okay. F of x is equal to 2x plus 3, right? And we're trying to find f inverse. Let me think. Okay. F inverse of x is equal to 2 is saying... what is x such that f of 2? No, that doesn't work, does it? Yeah. I wanted to maybe, like, do... This is a little bit more complicated. I want to do, like, oh, f of f inverse is going to give me x. And then f of 2. But that doesn't work, does it? I wanted to act like it was operating. Okay. Whenever this happens, this is the same thing as saying this is 2. Or sorry. It's not f inverse of x is equal to 2. My bad. Okay. This is what they're saying. F inverse of 2 is equal to something. Okay. Got it. Okay, this is how I wanted to write it. F inverse of 2 is equal to what? So, you can technically take the function of an inverse function and these will strip each other out so that you're just left with 2. And so you get that 2 is equal to f of what? Okay? So now you're solving for what when I take f of it do I get 2? This is f of x, and I want this whole thing to equal 2. But I need to figure out what I need to plug in for x in order to get there. So that's why you then say, oh, well, 2 is equal to 2x plus 3. And then again, you're just solving here for x. And so you would also get x is equal to negative 1/2. That's kind of the formal way to write it, I think, is to do it this way. That makes sense? Okay. All right. Determine if something's the inverse. Okay, so something is the inverse, and that comes down to this rule I talked about here, right? Do you see how f of f inverse just like stripped the f's off and you get the argument or the input variable or whatever. If f and g are inverses, then f of g of x needs to equal x. Yes. And also Jeff's right. And g of f of x has to all equal x. Yes. And then you could say because f of f inverse of x is equal to x. Right? Because these go away and you just get left with x. X is the identity function, right? Exactly. So if you wanted to do this, right? So you could do f of g of x. So that would be 3. So let's call this one, let me come up with colors for you real quick. Let's call this the red one. Let's call this one the purple one. Okay. So f of x, right? So f of g of x is equal to 3.
Nice.
And then this is going to be now g of x. So that's going to be 1/3 x minus 5/3. And then like plus 5. Well, no one could see yellow, Alistair. It's a terrible color. For streaming, at least. Yeah. I don't know, because I already used blue. Okay, alright, but here. Yeah, so f of g of x is equal to this. So you're basically taking what f of x was, right? Which is 3 of something plus 5. But then that something, g of x, is now 1/3 x minus 5/3. Multiply through.
Baby voice. Yes, okay, baby voice. Okay, so 3 times 1/3 is just 1. So this is going to be x. And then 3 times negative 5/3 is minus 5. And then you have plus 5. Minus 5 plus 5 is 0. So this just equals x. It is composite functions, exactly. Yes, yes, yes. So if two functions, when you take the composite of them, gets you just x, then they're inverses of each other. So this is correct.
So yes. They are inverses. Okay. Let's look at a case where they're not. I guess wow, they put it. Yeah, let's look at this case. I always found the way people are taught inverses with these polynomials when it's what? So let's look at this one, right? So again, let's call this the red one. Let's call this the green one. So f of g of x, that's going to equal to something squared. Well, that something squared is now negative x plus 1 under a root. And then you're going to say minus 1. So when you square this, you're going to end up getting... So wait, the square goes away. You do get x plus 1 minus 1. Okay, but I think the opposite doesn't work. You got to check both. Yali. So then plus 1 minus 1, this goes away, this is 0. So you do get x. So this is like okay. But let's go check the other one. Let's check g of f of x. Blue says he uses anger to get smarter. I do the same thing at the gym, dude. I say I just hate myself to perfection. It's like the Darth Vader quote. Use your hate. Okay. All right. So g of f of x would be this. So that's negative square root of something plus 1. And then that something... Oh, I see. This is actually kind of cool. Is x squared minus 1. You should check both. Yeah, just to be safe. So look what happens, right? These two cancel. And now you get the negative square root of x squared. That's technically negative x. No.
You're not that guy, pal. Trust me. You're not that guy.
Yeah. Not quite, Jeff says. Wait, the square root of x squared is just x, no? Oh, it's negative absolute value of x. Okay, fine. Technically. But, I mean, technically, Jeff, they said x had to be greater than or equal to 0. So I think we can just say this. Are you going to have to borrow against like 2031 now?
No.
Yes, and there's domain restrictions, yeah. F of x has to be positive. Okay, cool. Right, so that's where it doesn't work. Technically not wrong. Yeah, I agree. Okay. It is unnecessary. Yeah, okay, so then this one, again, whenever you see this, Yali, they're just asking, okay, if I replace this with 7, what is x? That's the simple way to do it. So then I would just move this over, and you get 0 is equal to x squared minus 4x minus 28. And then this is a quadratic, so you're solving for, right, what multiplies to negative 28, but adds up to negative 4. Does anything do that, actually? Fuck. 2 and 14? No. 6 and 4? Oh, this is ugly. 4 and 7? Negative 4 and 7 do, but those things don't add up to negative 4.
No.
I don't think they do, though, no? Narosky's typing. Welcome. Good morning, Narosky. Or good evening to you, I guess. Unless I did something horribly wrong. I don't think I did. Yo, yo, yo. Alright, yeah, you just have to use the quadratic formula. This is annoying. X equals negative b, so 4 plus or minus the square root. B squared, 16 minus. So plus 4 times 28. All over 2. So it's 4 plus or minus the square root of... what is that? 120, 116. Oh, 132 over 2. Wait, did I get it right? Wait, 80 over 2 is 112. No, 128. Sorry. Yeah. Okay. And then, okay, so what? This is, and then square root of 128 is 2 and 64. 64 is 8 and 8. That comes out. So it's 4 plus or minus 8 root 2 over 2. You can divide the 2's out. So you get 2 plus or minus 4 root 2. So there's actually 2 answers, I guess. Yeah. And that should make sense, right? This is a quadratic, Yali, right? Which means it looks something like this. So there's going to be 2 different values of x that allow f of x to be equal to 7. And if you want, Yali, I have a whole video on this. Well, it means it's not a function. Correct. Oh, is that what you're supposed to say? Technically, that it's not a function? I did a video on this one for sure. Where's my most recent one? Here, understanding inverse functions. So go check out this video. It's one of my more popular ones, but it talks about how like functions and inverse functions work. So hope that helped. Let me know. And I'll post all this in our Discord if you want to go join so you can see the screenshot. Thanks a lot for the help. I get it now. Do you think? Yeah. So, yeah, if you want it, so the screen is, yeah, here, let me put it into my Discord. So it's just easier for you to see. You could try to screenshot this whole thing, but man, this like sucks, right?
Disqualified.
So, here, and I'll show you how to get to it. Here, let me post it. So, in our Discord, which you can get to by going to the same website you went to submit the screenshot. There's a link here to say join our Discord. You should see it here in the homework help channel. One sec. I gotta refresh it. There you go. And there you are. There's your question, Yali. And then here's the whole picture for it. So there's the whole solution. Cool. You're very welcome. Nice. Cool. All right. Awesome. Great. Done. All right, Kempi, I will help you out.
Well done. Well
You rang. Okay, here. This is yours, Kempi? The Riemann sum, this is it? Want to do some optics for a break? I do have to go in like 10 minutes. I have to teach another student. I am still doing a little bit of private tutoring. I don't want to drop all my kids. I feel bad. Because they kind of need me. But, okay. Find the Riemann sum for f of x over the interval this, where these are the x's, and then these are the c's. Wow, uneven intervals? Oh man, Schmeat says I have a bio test tomorrow. Can I get some quick help? Biology, I think it's just a bunch of memorizing. Aren't they all entitled rich bastards? Some of them are some of them are pretty nice kids. I mean, they are definitely affluent, but they're nice kids. Some of them are nice. Like they genuinely want to learn. Okay, so this sucks. Do you want to do a left-handed or a right-handed, or do you have to do like what type of Riemann sum are you doing? Isn't there some there's some play here? There's some wiggle, right? What type of? Oh, they give you the C1s. Oh, they do. Okay. I see. Okay, fine. All right. So this would be sine of pi over 6 times whatever the width is in between these two. Yeah, unequal partitions, dude. It's fucking, dude, it's gross.
Bruh.
So that's pi over 4 minus 0. And then you would say plus sine of pi over 3. Dude, this is so terrible. And then this is pi over 3 minus pi over 4. Like, what does this teach you? It doesn't teach you anything. It just teaches you to hate math. And then plus sine of 2 pi over 3. And then pi minus pi over 3. Good night, Zach. Yeah, it's late. Thanks for sticking by for the late night hours. Appreciate you, dude. Come on by tomorrow. Narosky's gonna teach us some really elegant math. I'm super looking forward to it. No pressure, Narosky. Sine of 3 pi over 2, and then this is 2 pi minus pi. The teacher's psychotic, yeah, right? Dude, who makes their thing worth that much, right? Oh, thanks for the roses, Yali.
Good job.
Okay, there you go, Kempi. That's how you do it. It's up to you to, like, actually do the math. But in general, right, it's going to be, like, f of, they say, like, ci, and then it's, like, delta xi, where this is always, like, ci plus 1 minus ci. And then you're supposed to sum over all the i's. I'll just say sum of I, whatever. It's not quite right. Oh, what's not quite right?
You done messed up, Aaron!
It's xi plus 1 minus xi. Oh, yeah. Yep, you're right. You're right. Sorry, it's the x coordinate, yeah. I wrote that wrong. Wait, xi plus 1 minus xi. That's what delta xi is. I don't have to live 4 more years. Every time you get something right, it goes back into the balance. Okay. Cool. Make sense, Kempi? Nice. Cool. Great. Excellent. Good job. Yeah, it's really mean of your teacher to put, like, uneven intervals. Why would you do that? Okay, let's see. I still have a couple minutes. See what I can get done. We got a new one up from Gladiator. I don't think I've helped you out today, Gladiator. Yeah, this is kind of also the same one. Campy, this is, yeah, same stuff. You know how to do it. Pi, I would like to do yours. Oh my god, dude, what is this? Meniscus lenses? I assume a meniscus lens is two concave lenses that are like on top of each other, maybe? Yeah. Test got moved to Monday, dubs. Oh, that means we can help you on Sunday too. Yeah, so I think this is a meniscus lens, right? So you have a concave lens, and then I guess well, this is also concave. Oh, but it's, wait, what? Or is it convex? Okay, and then there's some like formula where it's like 1 over R1 minus 1 over R2 or something. Or, yeah. I would assume R1's always the closest one. R2's the furthest. Okay, let me see. I can do this in like 5 minutes. All right. Okay. Show that the bar reaches a terminal speed V term and find an expression. Okay. So you got a battery, you got a resistance, you got this. Okay, cool. I assume everything here is the resistance of the rails and the bar is effectively 0. Great. Okay. So what you learn is that d phi magnetic dt is equal to EMF. And it's like, I think it's technically negative or whatever. Okay. So magnetic flux is equal to magnetic field times area, which in this case is B, and then the area is this, right? Which is going to be some distance here, right? This is like the width of the area times the height, which they're saying is L. So that's going to be L times X. Okay. So d phi b dt is the derivative of this with respect to time. So as time goes on, right, the magnetic field does not change. The length of this does not change. However, the length of the box does. Right? So as this wire moves out, now you're suddenly enclosing more and more magnetic field, which is more and more magnetic flux. And then the rate at which you're enclosing more and more area is going to be equal to like the velocity of this thing, right? So that's also equal to BL, and then it's dx dt. But then dx dt, right? That's equal to velocity. So you get that BLV is equal to the voltage, so negative voltage going through it, and then this here is equal to the current times the resistance. Or actually, oh, you don't even need this. Sorry, what am I talking about? No, you're just good. You already have E of the battery. Yeah, great, right? Cool. I think that's all you need, right? Yeah, okay, cool. So, and then, yeah, this is terminal velocity. That's the velocity it's at. Okay, cool. Nice. So, yeah, V is equal to E over BL. I think that's correct. Right? Because the EMF is not changing, pretty sure. Yeah, that seems good. Okay, cool. So you actually don't even need the resistance. I don't know why they tell you the resistance.
Disqualified.
Oh, actually, no, wait, I fucked up.
That's dope.
I fucked up. Because if there's a current running through this wire, Gladiator, there's also a force on it. These tricky bastards. Tricky. Okay, this is actually almost like a differential equation. My bad. Okay, wait, sorry. Yeah. It's actually pretty cool. Okay, sorry. Okay, so, yeah, right? Okay. So, So, yeah, BL dx dt is equal to the EMF, okay? However, yeah, F equals ILB. So if there's current running in this direction, right, that's going to oppose it, I think. Yeah. IB F equals ILB. Well, let me think about that, actually. Sorry. Current goes this way. They do combat each other. I know that for sure. So, yeah. The combating one is, ILB. And then this one is going to be E over R. So E over RLB. Good. Has to equal... Do they tell... Do we know the mass? Do we know the mass of the rail? I feel like you need the mass. This is a tricky one. Because then this is d squared x dt squared. And then we already showed that dx dt is equal to E over BL. So I don't know, can you do like one of the integrals? Oh. I know. Okay. So wait, sorry. F equals ILB, right? But in order for there to be a terminal speed, the force needs to be equal to 0, right? So at V term, because this is equal to mass times acceleration, right? At V term, acceleration is equal to 0. Okay. So ILB is equal to 0? But what does that tell? That doesn't really tell you much, does it? Because then we know that I is equal to E over R. So E over R. Yeah, I do have to end the stream soon, though. I really gotta go. E over RLB is equal to 0. Man, how does this help you out, dude? What the hell? Alright, I'm gonna ask chat real quick. Then I gotta go. I didn't think about there being like terminal. Right? Oh. Sorry. The net EMF is E of the battery minus the back voltage from it moving. Got it. Okay. That's what I meant to say. Okay. I was looking, I was like, what the hell? Okay. Yes, okay. This is, so I forgot EMF is not EMF of the battery. Of the circuit. Okay. So you still get BLV is equal to E circuit, and that's like negative. So that's going to oppose the natural EMF of the circuit, of the battery. So you're going to have that E net is equal to E battery minus BLV. Okay. And then from this, this is the same thing as F is equal to, this is E net over R LB. But wait, where's the force come into play? Right, okay. Yes, and then the sum of the forces has to be 0, and then force has to be 0 for there to be... Oh, yeah, exactly. Okay, sorry, I don't know what I'm saying this. Okay. Okay, right, cool. All right, so then this is E battery minus BLV over R LB. And at term, acceleration equals 0. So F equals 0. So then 0 is equal to this whole term. Got it. Okay. Oh, so basically, E battery has to equal BLV. Or, yes, so V is equal to E battery over BL. Which I think is what they got. Yeah. E battery over BL. Cool. Alright, there you go. Okay, cool. Yeah, sorry. Yeah. This I forgot is not, that's not the total voltage in the circuit, or in this. It's the voltage provided to the circuit from the changing magnetic field. And then that competes with the voltage already in the battery. And when you look at F equals ILB, you care about the current in the rod, which is due to the net voltage in the circuit. That's a tricky one. That's an example of a tricky one for sure. But cool. All right. Good question, Gladiator.
Bing, bing, bong.
Wow.
Well done.
Yeah, you're very welcome. Yeah. Just remember that yeah, it's the change in magnetic flux is the change in the electric field. Not changing the electric field, changing the electric motive force, the EMF, just changing the voltage. Okay, cool. All right, that being said, let's close it out. All right, thank you everyone for coming to Actual Education Office Hours. Appreciate everyone's participation, questions, all sticking with us. Twitch was being evil today and crashed a bunch of times. So, yes, thanks for coming on by, getting help. Again, if you haven't already, go join our Discord using the website actualofficehours.com. And there, thank you, Fembox. Go check out our streaming schedule. So this is a schedule of all the other awesome math streamers and the things they do. So it looks like Penn Center is playing Ocarina of Time. We're gonna go say hi to him after this. But tomorrow, make sure you come on by at 4 o'clock Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern, because we're doing the Gilded Method.
Good job.
Featuring Naroski. So this is the first time I've run this stream, and it's gonna be a really cool, like competition math, elegant math, basically teaching us to do math without hitting things with hammers. So Naroski is gonna kind of lead that stream for us tomorrow, which will be fun. And then, yeah, if you want to see, he has a new channel I created called Naroski's Corner. And so this channel here in our Discord has all the different materials that he's already kind of like posted. We already have a few functional this is awesome. Okay, cool. So yes, they're already posted in Naroski's Corner. So go check these out. It's in the Discord. Oh, I forgot. I need to roll for what the game is going to be, because after we get our minds rewired to do math in an elegant way, we're also going to go play some games. And you guys vote on the games. But I need to run the, what is it? The votes. Okay, so let's see. So we have 4 votes for Fortnite, so let me do it right now. One sec. Picker wheel. So we will also, don't worry, Fembox, I will also, everything gets recorded, so you can watch the recording of it. And, you know, hopefully this will be something we do at least every other week. Maybe every week. I don't know. Depends what Naroski wants to do. Actually, I won't be able to next week because I'm out of town. But the week afterwards, yes. Okay. World of Tanks. And then chess. Okay, so we had 4 votes for Fortnite. Ooh, 0 votes for Roblox. 3 votes for Rocket League. 0 votes for World of Tanks. But then 4 votes for chess. Okay, so actually I'm going to take World of Tanks and Roblox off. Okay. Yeah, 4, 4, 3. Okay, here we go. Alright, we're going to spin the wheel. See what game we're playing on Friday. Looks like it's going to be Rocket League. Okay. So, make sure, go download Rocket League. I know it's available on, like, every single platform. We're going to play it on Friday. Anybody who plays a round with us at some point gets entered into a $10 gift card giveaway. So, it's meant to be like a fun time, like, hang out, relax. It's Friday night, you know? Okay. That being said, if you're watching us on Twitch, which I highly recommend, we're going to go raid a channel. I think we're going to go say hi to Pen Center. Is Pen Center on? Where is he at? Where's Pen? He said he was playing Ocarina of Time today. I don't see Pen. Sorry, where's Pen? Pen Center. Said he was doing it. Oh, he's not doing it. Okay. All right, we'll just go say hi to someone else. All good. Who have we not said hi to? We said hi to a lot of these people. Anyone else doing something cool? High Potential's going to sleep. Okay, go say hi to Physics and Depression. If you want to ask more physics questions, especially those optics ones and stuff, I'm sure he would love to help answer. So, enjoy. Have a wonderful Thursday. We'll see you on Friday. Peace.
Fun, and I chose 2 classes that were things that I was specifically not interested in. But I was like, if you were to